Hello, everyone, and welcome back to How to Build Like AWS, the show where we take real customer stories, speak to the developers behind them to show you how to build solutions like real-time fuel analytics for NASCAR. This is going to be a super cool episode. I'm so excited to get into it, and my dad has been very excited about me doing this one too, but let's get into it. Do you want to introduce where's my introduction? Owen, do you want to introduce yourself and tell everyone about your first application that you ever built?
Hey, Steph, thanks for having me. Hey, everybody. My name is Arvind. I'm a prototyper in the prototyping and customer engineering team. So the first app I worked on was actually a workflow-based solution for a leading asset management company. So there was in the early 2000s, and it's a system that was actually used by asset managers who actually have a really well-defined workflow every day that they actually follow to manage billions of worth of assets, right? So I had this opportunity to work as a full stack developer, and those were the days where like the likes of jQuery and Ajax were very popular, and it was also a workload where I got exposed to things like web services or message queues, even based architecture is another area that was really upcoming, and that exposure really helped me. The crazy thing about it is also getting into socket programming, which was very interesting. So yeah.
All right, if people in the chat know any of the words that Arvind just used, please let us know. But we have people watching from all over, people from Sweden, from the UK, from Canada. I love it. Please keep those comments coming in live. Any questions you have, let us know. Or if you're watching us on YouTube, drop a little car emoji in the video, in the comments. That's what I want to see. I love seeing socket. Jasper knows what socket programming is, so he's a fan. He knows what's going on. Brilliant. So today we're going to be talking about this amazing solution that I will make sure to share in the chat now, which is a blog all about the solution that I've been worked on with Prime Video and NASCAR, about how they created these AI-powered real-time insights so that people, while watching the NASCAR events on Prime, could see the fuel numbers, and then the commentators could actually give kind of behind the scenes information and knowledge about what's going on and why these things are happening, which is so cool. So check out that full blog there. But let's get into it. We're going to dive into a bunch of stuff. We're going to do more demos. We listen to your comments. We're going to do a longer demo in today's session. So keep those kings coming. Let's talk about the customer overview. So do you want to give us like a high level, quick summary of who the customer is and what their problem was?
Sure. So Amazon Prime Video was our customer. So for folks who want to understand what Amazon Prime Video is, it is one of the most popular streaming services that actually provides a vast library of movies, TV shows, and original content for Amazon Prime members. So Prime Video innovation team actually reached out to us, and they really wanted to focus on, creating an innovation on field strategy for NASCAR races. So this was in the spirit of really bringing engaging NASCAR broadcasts for customers. One of the key challenges with field strategy is currently there's absolutely no visibility to any of the field strategy of any of the NASCAR teams, right? So we thought we should use the concept of field strategy to actually start engaging the fans in unique ways. So that was the goal, right? To provide insights to the on-air talent so that now they could unlock these storytelling capabilities and thereby drive fan engagement. And for the folks who are wondering, why are we talking about field strategy here? And isn't that as simple as having maybe a fuel gauge in one of these cars? The answer is no. None of the NASCAR cars have fuel gauges in there, nor do they have any sensors which give us any fuel indicators. So that's the challenge we are after.
Brilliant. And so this is crucial for, like you said, those commentary people to be able to provide a little peek behind the curtain of what's going on and share more interesting, engaging information with the people viewing to make it that like in-depth viewing experience, which is super, super cool. I also see that someone's put a car emoji in. We love watching on demand. Keep those things coming up. I've even got a car shirt on today. If you can see, it's like people some swag out. I had a car in here. Very lucky I had this. Brilliant. So they have this challenge. They want to make sure they have the data. So we love in this show, we're teaching people how to build like AWS. So speaking to all those developers out there who are watching this, how do you start with that kind of big, broad challenge like that?
Yes, great question. I think there are a couple of things, right? One is we had the opportunity to work with the Prime Video innovation team. This is a team which has a lot of subject matter experts. So understanding the requirements from this innovation team, working back, because they are customers, we want to work backwards from the customer, understand what kind of data are we dealing with, what are the pain points for us to solve this problem, and then we get into the what should we, how can we negotiate on the scope, and how can we define success criteria. These are all really important basic steps to make use of. And then when it comes to the domain knowledge, I talked about how having access to industry experts within the Prime Video innovation team was a critical step for us to get there. And then when we also talk about defining success criteria, it's one thing to define it, but you need to be able to measure it quantitatively, right? Mm-hmm. So, for example, in our case, we wanted to basically say that we want to actually provide insights to fuel strategy or fuel consumption, for example, in less than 5 seconds. Right, that is a clear, measurable
5 seconds,
success criteria, that we can go after. And then we also had to say, okay, there are going to be 2 different interfaces. There's going to be some graphics for the fans, and there's going to be like a real-time dashboard, which will only be made available for on-air talent, so that they can actually spot the fuel strategies that occur in real time, and they're able to now come up with a reason saying, you know what, a racer who is in position 5, I think he could be the leader because of so-and-so reason, right? Because they see that fuel strategy developing as they speak. And that's really the key there. And finally, I really want to call out our AI services, especially, when we started developing the project itself. Amazon Q really helped us with gaining efficiency in terms of, code generation, unit testing, integration testing, and so on, right? So these were some fundamental things that we did to really get started and deliver it.
Yeah, and anyone in the chat, let me know who has taken on Kiro CLI. That is the new thing, which is a good kind of call out. Amazon Q is we're now moving, especially for the CLI, into Kiro CLI. Let me know in the chat if you have checked it out, because that is showcasing the speed of which this AI development is coming these days. I love what you said, though, the 3 kind of call outs for how you start. Domain knowledge, if you don't know, get people who do know. Success criteria that is quantitative and qualitative is so crucial for developing these kind of bigger projects. What does good look like? And also utilizing AI tools these days is significant to make sure that you can kind of build over real time. And I like what you also said, which is very working backwards. It's like, who is the end customer, right? We have both the on-air talent and the audience, and they're 2 very different customers. They have very different use cases of this information. What do they need to be able to see? Love the call out about Amazon Q. It does internal calls as well, not just code generation. Yeah, it is amazing. Kiro CLI rocks. We love it. Drop me a comment if you're watching on demand as well. I watch all these comments if you love Kiro CLI. Okay, brilliant. We are going to jump briefly. We're going to do a little bit more background, and then we're going to do some demos of things like Athena, Kinesis as well. So stick around for that. But moving into what was a big challenge in this development? We see customers when they're dealing with it, and people watching today will have big challenges. But what was the big challenge for you in this project?
Yeah. So if I were to bucket the challenges into different categories, I think the biggest one by far was the fact that we had to come up with fuel strategy insights when there is absolutely no ground truth data available. I talked about how fuel strategy has never been made visible to any broadcasters or the fans itself. So and the reason for that is there's really nothing out there which actually tells us, hey, here's the ground truth for any of these, right? So, for folks who understand, I'm sorry, go ahead.
I was like, remind us, what's ground truth if folks don't know?
Yeah. I was about to talk about that.
Oh, sorry.
think about ground truth as factual, verified information, right? That you can be used as a benchmark to measure against, right? So currently, as I said, if you want to understand what's the fuel consumption of a particular NASCAR car, there's really just no data available right out there that we can actually use that as a benchmark to verify our outcome, right? And this is exactly why I talk about having that liberty of talking to the industry experts and getting a validation from them is so critical, right? I think that was the biggest challenge, because that spoke to the quality of the outcome. Because if we drop that, we essentially lose trust with the on-air talent, right? And thereby this is not going to be successful. So that was, I think, a huge challenge for us. And then, of course, the other challenges were more in terms of meeting Prime Video innovation teams' stringent KPIs that they had, both on performance and accuracy. So I'd say those are two important challenges that we ran into.
Yeah, getting that 5-second turnaround was very that's a challenge when it comes to how much data analytics has to go into all of it. Brilliant. Absolutely. Just as a reminder, folks, if anyone has any questions, pop them in the chat, or if you want to get in contact, cat-thought-leadership@amazon.com is where you can reach us and follow up if you have any questions. If you're watching and you're like, hey, we need something similar to this in our industry, then let us know. Let's move on to the cool stuff. Let's talk a little bit about the technology that you guys use. So you mentioned some of them at the start, but give us a rundown of some of the overview of the technologies before we go into some demos.
Absolutely. So I think before that, if I can just take maybe 30 seconds to kind of at a high level talk about the architecture, I think that'll be super beneficial. So with NASCAR, think about each of these NASCAR cars having lots of sensors in it, and they can actually stream a lot of telemetry data, right? All of that data lands into a platform called ERDP, which is a data platform that NASCAR provides for broadcasters and teams. So we leverage ERDP because that's the source of all the real-time data streams that we actually get, right? So we run our subscribers for those data streams are running within ECS Fargate. We run that across AZs. And then once we've got all of that, we do actually some data sampling, some data filtering, validation, etc., and then pass all of that data streams back into Kinesis data streams. And once they land in data streams, that's our ingestion and storage layer. Then we make use of Amazon Managed Service for Apache Flink, along with Zeppelin, which is a tool provided within Flink as well for both analysis and real-time processing of data streams from Kinesis data streams. Once Flink, within Flink, well, Flink is like the heart of the system. It is what it actually uses both the AI model and a physics-based model to come up with these fuel analytics data points. And it basically pushes all of that data into another output data stream of Kinesis. Now, one of the things which we also do within Flink is we do make calls to the SageMaker AI inference endpoints for the AI inference. And then once we've got all of these fuel analytic numbers with us. We then use a combination of DynamoDB and AWS AppSync to actually build the real-time dashboard that our on-air talent make use of.
Brilliant. And we've got a fan in the chat, love Flink. I also like how many times you say the word Flink. It sounds like a great name for a product. Yeah, let me know in the chat who else loves Flink. Or if you haven't heard of it, then we're going to show a little bit in a second. But Flink, I guess, if you're talking about real-time analytics, that's like a really key tool for something you want to dive into, correct?
Yes. Yeah, I'm going to dive into that in the demo section.
Yeah. And before we move on, someone had a quick question. Thank you for questions. We love. Quick site for the dashboards, or are you using something else for your dashboards?
No, it is a custom React-based front end that we developed. As I said, we use that along with AppSync and DynamoDB as the data store. And that helps us really. Sorry, just to add, again, with AppSync and DynamoDB, we were looking at sub-millisecond latency at that point in time. So it really works amazingly well for us.
Yeah, and this person followed up with, are you making use of the new Quick Suite now, the new branding, AI? I am. I recommend it. We're doing a lot of analytics in the team about stuff that we do on live stream. So if you want an episode on using Quick Suite, then I tell you what I'd love is if you message me. And I read these emails, please, folks. I do. cat.leadership@amazon.com. Drop me an email if you would like us to do a Quick Suite deep dive on this channel. So let's get into it. Are you ready to get into some demos? Chat, let us know if you'd like to see some demos as well. But yeah, are we ready? Do you want to set this before we do? Actually, do you want to just set the scene of what you're going to show the folks?
Yeah. So I want to focus on one aspect of the solution, which is scaling. So I'm going to focus on three services. I'm going to talk about AWS Glue and some of the scaling capabilities that it offers. And then we'll look at how do we scale Apache Flink, and then also look at scaling Kinesis data streams, right? So it's going to be only scaling focused.
Brilliant. Okay, yeah. So how do we scale out this? Starting small, but make sure that you're able to grow when you're developing these solutions. All right, I will bring up your screen. So where are we in your console? And let me
okay, so this is AWS Glue. It is a service that you could use for building data pipelines, transformations, etc. So here I wanted to kind of walk you through a typical Glue job that you could create and have you focus more on the scaling configurations that are available within Glue. So just to kind of give you an overview, here's an example of if you just want to focus on the first two jobs. So what I did was just created 10 gigs of synthetic data, pushed that into an S3 bucket. And then I basically created a Glue script, which does all sorts of statistical calculations, and finally converts all of that into a Parquet format and pushes it back into an output S3 bucket. So with 10 gigs of data, you see two differences here, right? And I wanted to focus on the duration aspect as well as the capacity. We call them DPUs. And then there's a concept of the worker type. And think about this more as an instance type. You get compute and memory combinations there, right? But you see a difference in the duration of the job itself, right? The first job ran for 19 minutes, while the second one actually completed in just 3 minutes. Right? But there's also a difference in the DPUs, which is the capacity, right? So the first one, which took 19 minutes, only used 4 DPUs, while the one which completed in 3 minutes took 40 DPUs. Now, what is a DPU? Let's take a look at how you configure that here. So worker type, as I said, this is a set of predefined compute units that you're going to get with different vCPUs and memory configurations. So it is really important for you to understand your workload, what kind of transformations you're doing within your glue scripts. And then you could now also take a call on how many such workers you really need, right? So in this case, if I say I need 20 workers, and the fact that you have G2X essentially means that you're dealing with 2 times 20, which is 40 DPUs, which is nothing but the data processing units, right? So the cost, and it's important to understand, like, how do we even come up with these numbers, right? There's no magic here, right? There is got to be some testing that you really have to perform to arrive at this. And also, it is going to be a trade-off between performance and cost, right? Because the cost that you're going to be paying for a highly parallelized with lots of workers is going to be different, and it's going to be on the higher side compared to something that maybe you have just a few workers with a very simple worker type, right? So there's going to be a spectrum, and I want you to think about how do we arrive at these and what it really means for your business as well, because as I said, it is a balance between performance and cost.
Yeah,
now,
and
another
it's like
thing
about the success metric as well, just to jump in, that you need to get these things done. Maybe not this exact example is the speed, because this is a different part of the process, but how are you bringing in what is important? Is it speed? Is it cost? Like, where's the balance for it? Just so you know, we've got about 5 minutes left, so I just wanted to give you a time check.
Oh, absolutely. Okay. Sorry, okay. The next one I'm gonna quickly go into is Apache Flink. Now, what I have is, again, I have a simple Apache Flink pipeline running here, and I apologize if you're not able to view this.
Yeah,
I don't think the details of the pipeline is not very important in terms of what I wanted to show you, but this is how like a typical pipeline kind of looks like within Apache Flink. You've got different operators, and as you can see, I'm actually running I just initiated a script which actually starts dumping messages into Kinesis data streams, and you're seeing Apache Flink start to process all of these. But another thing I wanted to kind of showcase here is to your question earlier on, Steph, in terms of how do we really get started with all of this, right? Flink, for folks who have not really done it, can involve a lot of experimentation, and there is a learning curve to it. But a simple way of getting started with that is by using a tool called Zeppelin, which actually gives us this on-demand data analysis capabilities. Think about it as notebooks, right? Like Jupyter notebooks, where you're able to now put in some SQLs, as in when data arrives, you're able to run this kind of SQLs in an on-demand fashion and start performing your analysis right here, even before you actually start building a true Flink application using Python or Java, right? So that's the way you want to think about it, right? So in this case, as you see, I already have data coming in. And again, this is just a simple SQL statement, but you get the idea in terms of how you could start. Maybe you have some windows that you're using. You want to use tumbling windows or overlapping windows in Flink and perform some analysis. This is a great place for you to do that.
Brilliant.
Really quickly on the Apache Flink side of things, I want to again focus on the scaling aspect here as well. There's a concept of parallelism and parallelism per KPU. You will be charged based on the number of KPUs that are being allocated. So every KPU gives you a 1 CPU and 4 gigs of memory. So again, think about what is it that you're actually doing within your Flink application. You might want to do some load testing initially also to come up with these numbers. Parallelism essentially means how many operators are going to be running in parallel to speed up this whole entire process of analysis that you're performing within Flink. And then parallelism per KPU also can be configured, right? For example, in a single KPU, you could say, I need 2 more parallelism within that, right? So you're further increasing resource utilization on each one of them, right? So again, it's a balance. All of these is a spectrum of which has performance and cost on the other side.
Brilliant. And it's true, there's always this when you are building, and that's how we have to think about it, is what are the things, what does the end customer need? We have 2 questions that I want to jump to before we finish out the episode. Are there any specific reasons of using Kinesis over MSK in this use case?
I think we were perfectly comfortable with Kinesis because our team has done extensive work with Kinesis data streams in the past. And we really kind of understand, we feel very confident in terms of the scaling capabilities, and which is why we went into with Kinesis data streams. It is not to say that MSK doesn't scale well or whatever. It's just that a service that we've been very, very accustomed to making use of in past projects as well. And that worked absolutely well for us in this use case as well.
Yeah, it's always balancing skill and use case when you deal with these things, right? People always know whenever I build anything, I always use a Lambda function over something like a container just because it's my go-to. It doesn't always mean it's the best, but you should always try and find what is going to work the best for you. We should always advocate that. But there's also, when you're building these things, like these are prototypes, they want to go with speed and be able to deliver something for the customer to try before maybe developing in the future. And the second question was, could you use these metrics to allow gamers to drive a virtual car in another kind of race? Do you think that would be possible?
This brings up an interesting question, because I believe in one of the AWS conferences, we probably already have something like this. But the answer to this is yes, as long as you have the right telemetry and, as I said, with Flink, you're able to process all of this in near real time. I don't see a reason why we shouldn't be able to do that. And as I said, I think I've seen a similar one in one of our conferences.
Okay, yeah, keep an eye out. But yeah, these things, like as always said, you have to have the data to be able to make these decisions, to be able to access it. So finding out that, and like you also said at the start, is getting experts in to understand what is capable of that kind of thing. Alrighty then, we are coming up on time. Do you want to quickly show the Kinesis one? Very, very like 1 minute. Have we got time?
Yeah. Again, with Kinesis, we've got multiple options here. There's the on-demand, which is typically used when you have throughput requirements where you've got variability in data streams in the traffic itself. And the other one is, of course, using a provision mode where you can actually, perform some tests upfront, especially when you know what your data's input data stream sources are, and what is also understanding what's the variability there, right? Can you get sudden bursts of these streams coming in? So if you think about like a NASCAR race, there can only be 40 cars on the track, right? It cannot be more than that, right? So there's going to be so we could always say, all right, I know there's going to be 40, and then also with some of our testing, we could see that there's going to be like some consistent throughput that we could actually expect, and a provision model there really makes sense, right? Because we're not really looking at this sudden burst of data streams that could arrive. So this is, again, you want to think about provision when you can roughly estimate the amount of data that you're going to get, versus an on-demand, which is like an auto scaling where it can handle this unpredictable and variability in the data streams that you can actually get.
Brilliant. I love all the advice. So to summarize all of the kind of key points that we have had today, I think is number 1, have that success criteria. Number 2, have the experts in the room who know and understand the data is so important. And number 3, configure your services to scale as you need to complete the job that you need. Like we said, adding more of those DPUs meant the process sped up, but was more costly. So what's the balance between those things, and configure the same for the provisioned. A couple of last points is make sure that you check out the link I put in the chat, which is where you can see all the past episodes of this stream. Go on there, hit follow to make sure that you're up to date with all of the service summaries that I put out. Read the blog, which goes into real detail about how to do this. And also don't forget to join the AWS Customer Acceleration team linked in, very crucial. And finally, if you're heading to reInvent, you can see this talk live with Arvind to make sure you learn all about this. So come say hi to us. And if you say hi to us at any of those events, then let us know that you watched the show, which we love. Final things, email us, Thought Leadership at Amazon if you have any feedback, or if you want to get involved and talk to us about maybe deploying something similar. With that, we'll say goodbye. Thank you so much, and we'll see you next time. Bye.